Let's work on the problem 3.11d. You are given impulse response h of t as u of t minus 2 minus u of t minus 4. Find the convolution of this. So what we're going to do, we're going to try to use definition of the convolution first, and then we're going to look at the graph method. So based on the definition we have, that's going to be negative infinity to positive infinity. First h of 1t, u of tau minus 2 minus u of tau minus 4 times h of t minus tau. So whenever we have a t, we're going to change that to t minus tau. Then u of t minus tau minus 2 minus u of t minus tau minus 4. Then we're going to distribute this.
Integral negative infinity to positive infinity u of tau minus 2 times u of t minus tau minus 2 d tau. That's the first one. Second one, minus negative infinity to positive infinity u of tau minus 2 times u of t minus tau minus 4. And then minus integral negative infinity to positive infinity u of tau minus 4 times u of t minus tau minus 2 d tau plus negative infinity to positive infinity u of tau minus 4 times u of t minus tau minus 4.
So our variable is tau, and this is, when we graph it, it's going to be this. Okay? If this is tau, we're going to have a 2 right there. And for this, we have negative tau, so that is t minus 2, and it's going to go into that direction. Therefore, the red one will give us the lower bound, and then the blue one will give us the upper bound. Then we have tau equals to 2 to tau equals to t minus 2, and the tau minus, for the second one, we have an integral to 2 tau equals to t minus 4, right? When you let inside of the parenthesis equals to 0 and find the tau, that is t minus 4. And then the third one is going to go from 4 to t minus 2 d tau, and then fourth one going from 4 to t minus 4 d tau. If you take the integral for all of this, tau goes from 2 to t minus 2 minus tau going from 2 to t minus 4 minus tau going from 4 to t minus 2 plus tau going from 4 to t minus 4. We have a t minus 2 minus 2 for the first one, minus t minus 4 minus 2 minus t minus 2 minus 4 plus t minus 4 minus 4. And that equals t minus 4 minus t minus 6 minus t minus 6 plus t minus 8. This is kind of answer, but not really, because we know from h1 of t, when we graph this, u of t minus 2, that's u of t minus 2, and then we have u of t minus 4. So when we do subtract this, our h1 of t is gonna be this. And we're doing convolution of h1 of t and h1 of t. So t cannot be less than whatever the value. And if t is, let's say, less than 4 for the first term, then we are getting negative number. So therefore, the correct answer should be, we need to multiply u of t minus 4 for t minus 4. Anything below 4 is going to be 0. And then second one, we have a 2 of t minus 6, 2 of t minus 6, and then u of t minus 6 plus t minus 8, and then u of t minus 8. This way, when we have any t value less than 4, it's going to be 0. So let's test it. So if t equals to 4, then everything is 0. So our output y of t equals to 0. When t equals to 5, the first term is going to be 1, and then the second and third term is going to be 0 because we have a t minus 6 and u of t minus 8. Y of t equals to 1. When t equals to 6, then we have a 6 minus 4, which is 2, and then minus 6. So second term is 0, third term is 0. We have a 2. When t equals to 7, we have a 3 minus 2 times 1, and then plus 0. So that is 1. And when t equals to 8, we have 8 minus 4, which is 4, minus 2 times 8 minus 6, which is 2. And then the third one, 8 minus 8, 0. And anything beyond that, when t equals to 9, we have a 5, 2 minus 9 minus 6 is a 3, and then plus 1 equals to 0. So after that, everything is 0. So these are the value that we can get for the output. Now, let's use the graphical method. So we sketch that h of t right there. So now we know h of t, I'm going to call it the first one as a x of t, which is h1 of t, and that is 2 to 4. And then h of negative tau, do 1, 2, 3, 4, negative 2 to negative 4, and then h of t minus tau, so t minus 4, t minus 2. So h of t minus tau, now we replace h of t minus tau on the left side of the graph. It looks like this. Then we have, if t minus 2 is less than 2, y of t equals to 0. And that is t is less than 4. That's the first case. And then if we have t minus 2 is in between 4 and 2, then we have overlapping area. So that is t is from 6 and 4. Integral, we're going from 2 to t minus 2, and then d tau. That is tau going from 2 to t minus 2. That is t minus 2 minus 2, and y of t, t minus 4. So from 4 to 6, so when t equals to 4, you're going to have a 0. When t equals to 5, we're going to have 1. When t equals to 6, we have a 2. And then next scenario is going to be, we have 1, 2, 3, 4. If you have a t minus 4 is in between 4 and 2. So we're looking at the lower end. T minus 4 is in between 2 and 4. That means we have a t is less than 8, greater than 6, between 6 and 8. We're going to have integral. We are going to go from t minus 4 to 4, and the tau, that is tau going from t minus 4 to 4. Then y of t equals 4 minus t plus 4, which is 8 minus t. Then when we have a t equals to 6, we already looked at it. So now we have a t equals to 7, then it's going to be 1 when t equals to 8, and then it's going to back to 0. So 5, 6, 7, those are the cases we can get output value, which is the consistent with what we have here, 5, 6, and 7.